early on within the presentation, we mentioned the notion of mesocycles. Remember we said that mesocycles, in essence, are kind of the monthly structures. But actually, mesocycles have their own unique structure, which are determined by the objectives of both the phases and the periods of training. So what we think about this, well, the common length of a mesocycle, as I've got here, is about 4 weeks, right? Because it fits into very neatly into kind of your calendar month. But you may use longer mesocycles, 6 weeks, 8 weeks maybe, depending upon what the objective is the preparation phase or the competition phase, or what the objective of the athlete is. And also when we go into the taper, which is where we start to reduce the overall training load, we may well have a specific duration of mesocycle that is not standardized. So the structure of the mesocycle is governed really by the number of microcycles. Remember I said a microcycle is generally a week's worth of training. And so what we do with the mesocycles, we use this construction to identify the load progression that we're looking for within our athlete. How are we getting that kind of progressive overload as we go through the year's worth of training? So the way they're designed are a little bit like this. We have what are called developmental mesocycles. So you can see here, you've kind of got this graded increase. So we're developing the athlete. It's not stationary, nothing is remaining constant. So we're going increasing in training load, increasing training load, and then we have this recovery. Remember that, as I said earlier on, the recovery microcycle determines the end of one mesocycle's worth of work. So we use these to kind of get a uniform increase. You get super compensation. Why? Because here, this is where the recovery comes in. So if you imagine you're building fatigue, you go into recovery. As we start to recover, we get super compensation. So these are kind of composed of lower loads of training. So we might have lower intensity, but we might have higher volumes. They kind of fit quite well within the preparation phase of the annual plan. Not solely, but that's generally where they're recommended. We then have the notion of maintenance and regeneration. So the example here is kind of a bog standard representation where there'll be no real change. And one of the issues with this approach here is if we don't change anything, we start to lose adaptation. So the notion of maintenance doesn't mean just keep it the same. Actually, what it means is that you might want to undulate a little bit. So where you've got 40% load here, you might go to 50, then 40, then 50. And oddly, that allows us to maintain fitness better than simply keeping these loads the same. So tend to be much more common actually in those kind of undulating periodization plans, but also I mentioned earlier on in the competition phase where we may start to just use kind of an undulating approach to control the fatigue, both that biological and physiological and emotional fatigue. So there's less emphasis here on adaptation because there's less fatigue being produced. So it's quite useful, particularly maybe where you're trying to transition from one very intense mesocycle to the next mesocycle. So you may use that as kind of an interim block of training. Maybe used in terms of recovery for regeneration. So we talked about recovery and regeneration in a previous session, but may fit quite nicely into that notion. And again, tend to fit in the preparation phase, but you can see how they would have a place in that competition period of training where you're trying to regulate the fatigue. Then we have what are called crash or shock cycles. And we've mentioned these in a session previously, which was the session on theories and models of training. But the notion of these is, as you can see in the graphical representation, these are high load microcycles. So what you do is create a crashing effect. Fundamentally, you really go for an overload in the athlete, that you've got really 3 very intense microcycles worth of training, so you're creating a really significant fatigue-based response. And the greater that fatigue-based response, of course, what you're going to drive then is a greater biological adaptation, assuming you have sufficient time devoted, as we have here, for recovery. So the supercompensation is great, it's big, but of course it comes with an awful risk. You can't apply this to less experienced or less well-trained athletes, because all you're going to do is you're going to create the notion of burnout. which is leading them down what we call the spectrum of underperformance syndrome, which has huge negative consequences for some athletes. You have to be very, very cautious about applying this. Certainly really only works well when you've got experienced athletes. Where do you apply these? Well, generally you tend to use these when you're moving from a major period of training, so the end of preparation, into competition, and sometimes you see these used right at the end of the competition phase, as you're heading into the taper, as the final big push to evoke the biggest biological gains that we can get from the athlete. Which brings us on to the notion of the peaking mesocycle, and this is the kind of how you bring the athlete to preparedness. You're reducing the fatigue curve, you're bringing the athlete preparedness curve up, and so what this does is it promotes greater supercompensation. But you have to be very cautious, and this will be covered in a subsequent session, which is on tapering and peaking. It's not simply about just reducing the intensity or the volume of training. If you do that, you start to detrain the athlete. So it's about getting that balance right in order to allow the athlete to get the optimal response. And it's the notion of how we taper, and understanding that tapering is so important to allow for regeneration, to get the athlete to that point where their preparedness curve is at the highest and their fatigue curve is at its lowest. And then the final section, really think about are microcycles. Remember that microcycle is roughly a week's worth of training. And the thing about microcycles really is their structure is very similar to what you see with mesocycles. So remember that they are basically a group of training units. Their focus comes from the overall training goal, and then we have kind of an optimal sequencing within a microcycle, and this is really important. So one of the things you have to remember is that when you are kind of building training, there is an optimal sequence within the microcycle, within the week's worth of training. And it's kind of this, and you can see it kind of goes from medium intensity. Interestingly, we don't suddenly end at maximum, we actually have sub-maximal here. And so what you have to think about is the way you move from the week. So you would start the week actually doing your kind of neuromuscular training. You wouldn't start the week doing high intensity or really quite prolonged endurance. The reason being that you're carrying that fatigue. So if you've got fatigue from high intensity training, sprint interval training, even lactate threshold training, or hypertrophic training, and then you go and do subsequent sessions which are neuromuscular, you're not going to get the best benefit because the fatigue is actually impacting on the force generation. So what you have to think is, I do the kind of the high force, the kind of the fast force production exercises and training at the start of a microcycle, and then I progressively move through into the kind of the strength and then into the endurance-based exercise, as you see in this example here. And that allows you to kind of sequentially phase the fatigue across that microcycle's worth of training. And you see this here, this is a plan for a gymnast, but you can see it kind of structured here in terms of these are kind of our mesocycles, and we've got kind of a single microcycle here, and then you've got in essence what's happening on each day of the week, not the sessions, but in essence the overall load. And remember that those loads would then conform, and there isn't one on here, but would conform to what the stress curves would look like at the bottom of the plan in terms of the intensity and the volume. So very much like we had with our mesocycles, we have developmental microcycles. They have very similar objectives. It's about kind of the balance between the volume and the load. We have crash microcycles. So you might have, if you've got a crash mesocycle, by definition, the microcycle has also got to be crash based. It's got to be intense enough to conform to the overall objective of the mesocycle. So you have kind of sudden increase in demands. It's associated generally the preparation phase. You have a minimum kind of 4 really high intense sessions, but then you would generally have a regeneration cycle either at the end of one of the microcycles or at the end of the overall mesocycle to which these have contributed. And of course, not surprisingly, as we have with mesocycles, we have regeneration microcycles, and these conform when you think about we had a developmental mesocycle, remember we have progressive overload and then a recovery week. The recovery week is that regeneration microcycle, which is allowing for the adaptation, it's allowing for the recuperation prior to moving into the next mesocycle's worth of training. And this is kind of how they are structured. So, okay, these are kind of our microcycles worth of training. So here we've got 3 microcycles, each one is a week, and then that might conform to 1 mesocycle. Okay, it depends on what the overall objective of the plan is looking like.